GPT-like model inference strategy works during generating outputs. So suppose this is an example implementation. If we run this model, we can see that this model generates this output value. So how this actually happens? The input is every input moves you, then it generates the toward finding an ideal life. And so how this the GPT-like model generates this output. So first, after getting this input value, this model program converts this input value sequence, the input value, into tokens, and then converts it into the token IDs and pass it to the model. Then the input IDs will pass to the embedding layer and the transformer layers and the other layers, and finally it will generate this output. So I will not go through that how in the GPT model, but I will go through that how this next tokens actually generated, because in the GPT-like model it generates token by token. After every iteration it generates one token, and then it generates the next token. So what happens here actually, here the generation function, it gets out the model, the GPT model, then it gets that input IDs. Like here I have added this input value, and it passes this input IDs, and then we have another parameter that max number of new tokens, then the context size, maximum context size, then the temperature parameter, then top k, and the end of the sequence ID. So what happens here, that it iterates over this maximum number of tokens, and it generates a new token each iteration, one by one. So what happens here, first we check that if the context size is larger in the input token ID, then we truncate it, only take the most recent context size tokens from the last int, not from the beginning, actually from the last int. So this is for all of the base value, and then we truncate it for if the number of tokens exceeds the number of context size, we take the last number of tokens. Then we generate the logits. So during inference we don't need the gradient, so we can generate the logits with no gradients. So the logits shape will be here. So for the inference and for the simplicity, I am using here only one base size for the one, so this will be the base, and then the next dimension will be that number of tokens, that in that case will be one, because it generates one by one token. So it will be input token IDs, number of input token IDs plus I, and then the vocabulary size, I mean the number of tokens has been used during the training in the model, the number of words, number of tokens we have used in the model. So that is the vocabulary size. Over this vocabulary size it will generate the logits. Because we will only generate the last token, that's why we will take the logits for the last token only. So in that case, after converting it, then the shape will be 1 and the vocabulary size. So this 1 for this number of base, and then the logit for each vocabulary, the last for the last token only. Now we have this logits, then we go through this top case sampling strategy and the temperature sampling strategy. So I will go in detail how this works here. So for this top case sampling strategy, we select the top number of tokens with the higher probability that the model has generated. Here when we apply the top k, it returns the top logits that has the higher values, and then we select the minimum value from that logits, and we apply to the logits that if some logit value is less than the minimum, then we replace it with the minus infinity. Let's go through an example to understand it clearly. So here, suppose instead of the vocabulary size, we, for understanding here, I have only used the logit size is 5 and with top k value is 3. So what happens here after applying this output value, suppose these logits are this value, after applying top k value we get this. It selects the top 3 values. So here 2.3, 1 and 1.7, and it does not select 0.8 and 0.5. And then from this top 3 values it selects the minimum value. So this is actually the largest top kth value, actually the third value. So it's 1, and after applying this value, what it does actually, if some logit value is less than this mean value, then we replace it with the minus infinity. So what happens here, we replace we replace 0.8 and 0.5 with minus infinity. We use minus infinity because when we apply later with the softmax, we use softmax, it will convert to the zero probability. Essentially it will removes from the selection probability. What the impact, actually it sharpens the sharper sampling, fewer surprises. We removes the lower values, only select the top number of values that we passed, that top k values like 3 here. And later we use the temperature parameter. In the temperature parameter, what happens, if the temperature value is greater than 0, then we use this multinomial sampling strategy, and if not, in that case we use argmax. So what does actually, if temperature value is 0, in that case argmax will return the value, the index value with the highest value. But if not, in that case what we do here, we first convert the logits by dividing the temperature, then we apply this softmax activation function that will generate the probabilities over these logits. With softmax probability, those will be sum of 1, and then we apply this multinomial function to select a token. So let's go detail here with an example to understand it clearly how this works. So here, suppose we get these input values from our previous selection. So now we have, after applying the top k, we have this input value. Now when we apply the temperature value for 0, we will see an example that if the temperature value is 0, what happens, and if we use temperature value 0.5, 1 or 1.5, what happens. So if we use temperature value 0, then it will go to the else section, and in the else section we don't use here the SQL logits or softmax probability, but we use here argmax function. What argmax function does, it finds the maximum value from this array and returns the index. So here the maximum value is 2.3 and the index is 1, so it returns the index 1. Now if the temperature is 0.5, what happens here, this temperature value, we divide the logits with the temperature value, so we get it will be, the value will be doubled here because we are dividing with 0.5. 2.3 has been 4.6, 1.0 has been 2, and 1.7 has been 3.4. And we can see that the difference here in between 2.3 and 1.0 is 1.3, but here the difference between 4.6 and 2 is 2.6. So the differences from this second and third value has been increased. As a result, the softmax probability, we get the softmax probability like this, that for the higher value we get here 0.78, and for 2 second value we get 0.5, and for 3.4 we get 0.17. As a result, when we apply the multinomial, most of the time it is supposed to select index 1. So it will select 78% time index 1, 5%, only 5% index 2, and 17% for index 3. When we pass the temperature value 1, what happens here, it scaled the values will be the same, but the differences we can see here that from this two value is only is 1.3. Previously it was 2.6. As a result, we got higher probability for the second value. But for now, we are getting the probability 52%, 0.52 for the second value, 19%, which has been increased value for than this previous 5%. Now we are getting 19% probability for the second value and 29% probability for the third value. As a result, most of the time it will select the second value or the third value. And if we apply this temperature value 1.5, in that case what will happen? Because we are dividing it 1 by 5, we get this value 2.3 will be 1.53, 1 will be 0.67, and 1.7 will be 1.13. But we can see that the difference has been decreased than previous values. At the beginning it was 2.6, and then it was 1.3, and here we can see that it is less than 1. So as a result, the softmax probability will change. We get the probability for the second value only 43%, and the third value probability has been increased to the 21%, and fourth value probability has been increased also to 36%. As a result, we get more varied type of selection strategy here. So the impacts here, if we use temperature 0, it will select index with the following greedy strategy. Always it will select 2.3, but for if we use a temperature value different, based on that it will select the other tokens with a different probability based on this. Like if the temperature value is less than 1, the Sharper distribution favors top tokens. Like here the first token has been 78%, and if the temperature gets more than 1, it flatter the distribution, promotes exploration. Like this smaller value gets here 21% chance to be selected. As a result, it is a more varied selection. So this multinomial actually selects how this selection happens. For deeper understanding, I have added another slide to discuss that how multinomial actually selects the index. So it uses a cumulative distribution function, CDF. So how does that work actually? The input value sum up needs to be always 1. As a result, we use the softmax that makes sure that the sum up of all of the probability will be always 1. Then what this multinomial does, it creates a CDF, so cumulative distribution function. So it's 0.1, then it sums up with the next value, it gets 0.4, then it adds 0.4 with 0.6, and it gets 1. And then it draws a random number. Like for each sample, a random number in between 0.1 is drawn, and then based on this value, if the random value is 0.25, then it will fall in between this 0.1 to 0.4. As a result, it will select the index 1. If the random value is 0.8, we can see that it is in between this value. As a result, it will select the index 2. And if the random value could be like 0.05, in that case it would select the index 0. So like that way, it makes sure that all of the values can be selected based on its probability distribution. So probability distribution means that this value has a chance of 60% to be selected, this value has a chance of 30% of selected, and this value has a chance of 10% to be selected. And this multinomial distribution, probability distribution, that makes sure that each token is selected based on its probability. So now we get the next token ID here by following this sampling strategy. If the temperature is 0, then it will follow the greedy strategy, and if we use a temperature, based on the temperature value, it will select the next token. Maybe it will be more exploration if the temperature value gets more than 1, or if gets less than 1, then it will select with the highest logit value. And then we check that if the selected token is int of the sequence ID, then we don't continue this loop until the max number of new tokens. We int here and add that token to the input token IDs and return here. But if it is not the int of sequence ID, then we add it to this input token ID, append it, and then we iterate through this loop over until through this loop and generate one by one token. Maximum we generate maximum number of these maximum new tokens if the model does not get any int of sequence ID. So that's how the GPT-like model generates outputs and uses sampling strategies to get the output to get the outputs. And so this is for simplicity I have used here only 1 as a base size, and because this is an inference, so most of it is easier to assume that the base size is 1, but sometimes the model can generate outputs as a base. In that case, what we need to do, we need to initialize an array here, flag array, and need to check here that all of the sequences has been reached to the end of the sequence. So the changes will be like here, that we need to initialize a flag here at the before the for loop that initialize with 0, and instead of using this checking, we need to use this type of checking. What it does actually, it checks that if some of the int of the sequence ID is there, then it updates this flags, and if this flag is actually end of the sequence, then it does not include the last token, otherwise it will include the token IDs. And finally it checks that all of the flags have been on. If all of the flags have been on, in that case it will break the loop, otherwise it will continue until the max number of tokens. So that's all actually, and that's how the GPT-like model generates outputs in the inference. So that is the inference strategy, sampling strategy for the inference for the GPT-like model. Thank you everyone.